Okay, today we're talking linear relations. We're specifically talking about two different types of linear equations we can use. So what's a linear relation, linear equation, linear function? Anything linear just has to deal with the simplest form of that thing. So a linear equation is an equation where the x's and the y's are separate from everything else. They're never multiplied together. They're never divided. They're never taken to an exponent other than one. They're never square rooted, none of that stuff. They're just each, the x and the y are each in their own term, only multiplied by some number. That's all we can do. That's it, okay? If that's all that's being done to the x's and y's, then it's a linear equation. Okay, so one of the types of linear equations we're going to talk about is standard form. That's useful to us in certain contexts. Why do we have different forms of linear equations? Because we do different things with them. This is something we're going to use quite a bit when we solve linear systems, which is coming up next unit. Okay, so what does this mean? Standard form just means it's going to be written like this: ax plus by equals c, where a, b, and c are just numbers. We call those parameters in math when they're numbers in an equation whose values we can change to make different versions of that thing. In this case, to make different lines, we would change the values of a, b, and c. We would dial in specific values of those three parameters to build any of the infinite lines that we could graph in the xy plane, okay? There are some rules. The rules are, first of all, rule number one is that a, b, and c are integers, okay? Rule number two is that a is positive, can't be negative. And rule number three is that the greatest common factor of a, b, and c is 1. I gave you these rules, and I'm going to turn around and break these rules later in the year. It turns out that a lot of these rules we don't really care so much about eventually, but for now they're useful to have. They're going to help us for now. Eventually, as you get better at math and you go further along in math, we might discard some of these and not worry about them. But it makes things easier to stick to these three rules for now, okay? All right, so two things with standard form we want to be able to do. We want to be able to write equations in standard form, and eventually we want to be able to graph equations in standard form, although we're not going to worry so much about that right now. What do we have to do with number one, example number one up here? It looks pretty good. It's almost in standard form, but I'm violating one of my three rules. Which one? In this one right here? I want to have the x and the y on the left, which I do. Yeah, that's it. A is negative and it needs to be positive. So we're violating rule 2, aren't we? We've got that negative 5 times x. The coefficient of x, which is a, has to be positive. Okay, so how are we going to fix that? Let me rewrite this. What am I going to do? If I've got an equation, and if I want to change that negative 5 to a positive 5, how do I do that? What do you think? Okay, I could either divide by negative 1 or multiply by negative 1, right? They both accomplish the same thing. Because it's an equation, I'm going to go ahead and multiply. I think it's easier when we're trying to just change the signs in an equation, to flip the signs. It's easier to write out multiplying than it is dividing. Okay, I'll show you why. Like, all I have to do if I want to show the work for multiplying by negative 1 is put the entire equation in brackets and put a negative sign out front that I'm going to distribute. Okay, that's pretty easy. Remember, it's an equation, so whatever I do to one side of the equation, I have to do to the other side also, right? So I'm just going to distribute this negative through. And when I multiply an equation by negative 1, it just changes, flips all the signs. That's it, right? So this one becomes positive 5x minus 6y equals positive 12. And I'm done. That's it. Okay? Make sense? That's in standard form. Okay, how about number 3? What's wrong with number 3? Okay, the 24, the constant has to be on the right side of the equation, doesn't it? So what am I going to do? Add 24 to both sides. There we go. So we add 24. Those guys cancel. Hey, that's looking pretty good. Now we get 9x plus 6y equals 24. Okay, good? We sure?
No.
Are there any other rules I'm still breaking? Anything I'm still breaking there?
Yes.
What is it? What do you think, Brennan? Yeah, rule 3. Yeah, the greatest common factor of A, B, and C is not 1. Is there another number other than 1 that divides into 9, 6, and 24? 3 does. Yeah, exactly. So I've got to divide everything, both sides of the equation, by 3. Okay, so what's that look like? Well, it looks like this. It looks like dividing the whole thing by 3. But when I divide a bunch of terms, it looks like a common denominator kind of, right? I'm just going to split that up and divide each term separately by 3. And what do I get if I do that? Well, 9 divided by 3 is going to give me 3x. There you go. And we're done. Okay? All right. How about number 5? What's going on there? What's the problem with that one? Well, okay. I mean, indirectly, but which rule am I violating there? Integers. Yeah, A, B, and C have to be integers. What are integers again? Okay, positive or negative whole numbers, right? Could be positive or negative. So I've got to get rid of those fractions. Well, we're getting to be pros at that. We've been doing that for a while now. Let me rewrite this. What do I do to clear those fractions? I distribute a 12 through. Okay, we're getting pretty good at this. There was still a little bit of confusion about how to do this on the test, but it's getting much, much better. So one more time, let's go through this together. So if I'm going to clear fractions, I pick the 12 because the 3 and the 4 both divide evenly into it. So when I distribute, I'm going to take advantage of that. I want to reduce first to cancel the denominator. That's the whole point, right? To clear fractions is to cancel the denominators. And then whatever I'm left with, I multiply by what remains, which is just the top. So 12 over 4 is 3. The denominator's canceled. I just multiply that 3 by the top and get 9x. There you go. 12 over 3 is times the top, which is -1. So I get -4, and then I'm multiplying by y. And then equals 1. Is that right? 12, exactly, because I've got to distribute this over there as well, don't I? So I get equals 12. And I got it. Okay. All right, you guys, real quick. We're gonna make this as quick as possible. Do number 6. Do number 6, please. Go to the boards and try that real quick. See if we can do this in like 2 minutes. Okay, so then what did we do? We had to clear the fraction by multiplying through by 6. So we're going to distribute a 6. If I distribute the 6 here, I'm going to get a 1x. If I distribute the 6 there, I'm going to get a 6y. There, I'm going to get a -12. Good, we got rid of the fractions, but what's the last step to put it into standard form? I got to subtract the 6y to the other side, and then I got it. Perfect. Okay, give me thumbs. All right. Okay, last issue for today, slope-intercept form. This is one of those game show equations. Like if you're ever on a game show and they ask you a math question, it's going to be one of about 5 things, and this is one of them. What's slope-intercept form of a line? Y equals mx plus b, right? We all have seen that many, many times. And I could write it in function notation if I want to, change the y to an f of x, but usually we just leave it y equals mx plus b. What is m? What does that stand for? In slope-intercept form, what does the M stand for?
Mass.
No. You guys really don't remember this? Slope? Is that ringing a bell? Okay. And what's B? Y-intercept. There you go. Okay. So M is slope, B is y-intercept. Let's talk slope for a second. So slope is, it's the constant rate of change between the points. We think of it as rise over run, right? There are, before we talk about the different types of slope, let's talk about how we calculate it. So you're used to that equation probably, right? Slope equals rise over run. Remember that equation. That's the slope equation. Y2 minus Y1. Really, technically, we say Y sub 2 minus Y sub 1 because those are subscripts. Superscript, super means above or high. Sub means low or below, right? Like subterranean means you're down in some passages that are below the earth, right? Um, but we just say Y2 and Y1 to make it short. What do those mean? Y2 minus Y1 over X2 minus X1. What does that mean when we put a subscript next to a variable like that? It's not like, it's like if we put a superscript there, it means an exponent, right? We're squaring it or something. These are different. What this means is when we put a superscript, it means, okay, those are specific values of the variable. They mean something specific numbers we're going to plug in. So to calculate slope, we need to calculate rise over run between 2 points in the xy plane, right? We have to be able to distinguish one point from the other. So the first point we call x1, y1. Those are the coordinates. Those are numbers. Those are the coordinates of the first point. The second point we call x2, y2. Those are the specific coordinates, the numbers that tell us where the location is of the second point in the xy plane. So we're plugging numbers in here to get a slope. What kind of results could we get? There's 4 different kinds of slopes. What are they? For example, what about a line like that where an ant walking on the line from left to right? So the ant's always going to be walking towards the positive x direction from left to right. If the ant is walking uphill from left to right, what kind of slope is that? How do we describe that? Well, I want something more basic in general. What kind of number? Describe the types of numbers that would describe that slope. No, it could be fractions. Positive, that's it. They're positive, yeah. Okay, a positive slope means an increasing slope. From left to right, the ant is walking uphill. So then, by contrast, if I'm decreasing from left to right, what is that? Negative, yeah. And that makes sense if you think about it, right? If I pick 2 points on this line, and I'm starting at the left one and moving to the right one, my rise is going to be positive or negative? Positive. I'm going up. That's positive. My run is positive. And as long as we go from left to right, which we always want to do, the run will always be positive, right? You never want to go from right to left on a line. When you're making slope triangles, you always go left to right. So positive divided by positive is positive, right? Okay, what about this one over here? So now we've got 2 points. If we go from left to right, my rise is positive or negative? Negative. My run is positive. Negative over positive is negative, right? That's our rule for division, our sign rule. Okay, how about this one? What kind of slope does that have?
Positive, negative, or negative, positive, or it could equal 0. Is it a 0 with line through it? No solution?
I'm getting lots of answers. Somebody raise your hand if you think you got a, what do you think? It's 0. Yeah, how come? Well, let's figure out why. Why is that 0? I've got a point here and a point there. Going from left to right, what's my rise? 0. Okay, so I get 0 divided by my run is going to be some positive number, right? 0 divided by a positive number. 0 divided by any number is 0. Yeah, you bet. So then we end up with our slope is 0. Okay, the only type of line we haven't drawn is a vertical one. And this is going to be a strange case. If I take 2 points on a vertical line, I said you always want to start with the left point and go to the right point. Well, those are lined up vertically. Neither one of them is left of the other nor right of the other, right? Let's just start with the bottom one though. What's my rise going to be? Positive. What's my run going to be? 0. I'm not moving horizontally at all. Okay. Can we do that? That's one of our rules with real numbers. We can't divide by 0 and we can't take a square root of a negative number. Those are the only 2 rules we have to follow. So that's impossible. We can't do that. And so therefore we say that the slope is undefined. You might have called that in the past. I bet you maybe you called that no slope. Is that true? You remember doing that? A lot of times that's how we teach it, like in grade school and sometimes in middle school. I hate that. It's so bad because it's not that no slope sounds an awful lot like 0, doesn't it? If you have no oranges, I have 0 oranges, right? So, I mean, no slope, we say undefined instead, and then you can't confuse them. Undefined is a vertical line, okay? All right, so now last issue for today. We want to be able to graph some lines. We got to, first of all, write the equations in slope-intercept form and then graph the equation. How am I going to graph a line like this one right here? How do I graph any line? What's my strategy to graph a line? You guys have done a lot of this in the past. What do you think? How do I graph a line? How many points are required to specify a line? 2. Okay, so I just need 2 points. If I could ever just plot 2 points, I could just connect and extend and I've got my line, right? So I need 2 points. Well, what form is that equation in number 7? It's in slope-intercept, right? It's in slope-intercept form, y equals mx plus b, right? So once it's in slope-intercept form, we can just by inspection, just by looking at the equation, we can tell the values of m and b, can't we? What's the value of m? What is it? 2/5, yeah. What's the value of b? 7. Okay, so they gave us 1 point directly. What point do we know right now? 7. We know the y-intercept is 7. So where is that on my graph? Tell me how I'd get there. Okay, from the origin on the y-axis, I just go up 7, right? So I end up right there. There's my point. How am I going to get another point? They only gave me 1, but the math gods also gave me a roadmap to the next point. The slope always acts as a roadmap. What is that roadmap telling me? Where do I go to get from my first point to the second point? 2/5. Okay, so that's telling me a rise over a run, isn't it? Right? So from this point, I'm going to rise how far? 2. And I'm going to run how far? Oops. Okay, to get to this point. Now that's not a very convenient place though. It's off the graph. It would work. I mean, if I just moved my graph, if I made it a little bigger, I'd be fine. But what trick could I do to find a point that's on my graph? Oh, okay, I could do the opposite, right? I could go down 2 and left and back by 5, and that would also work. Okay. To there. And now that I've got my 2 points, I just connect and extend, and there's my line. Voila. Okay. How about number 10? Okay, that one's not quite in the right form yet, right? Does that make sense? I got to be able to put it into slope-intercept form before I can tell what the slope and the y-intercept are. Okay, so good. I've got to add 1 to both sides. And what else? Subtract 4x. There we go. Right? And how do we know that? Because whenever we're putting an equation into slope-intercept form, it's easy to do. What are we doing? Easy. We're just isolating y and following PEMDAS to simplify. That's it. So getting the y by itself and collecting like terms on the other side. That's it. That puts it into slope-intercept form. Okay, so then we're going to subtract. We said we're going to subtract the 4x from both sides. And what do we get then? We get the y by itself equals 0 minus 4x plus 1. Bingo. Okay, so what's my slope? What is it? -4. Now, if I want to think about that as a fraction, what would the denominator be? Okay, good. 1. If there's no denominator, it's an implied 1, right? And that's useful because now it looks like a rise over a run. All right, what's my y-intercept? 1. Okay, so I know a point to start with. There's my anchor point that I'm starting with. I know a roadmap. What's my roadmap telling me I'm going to do to get to the next point? Okay, I'm going to rise by -4, which of course means I'm going down, right? Oh, we didn't want to do that. I want to do that. And you guys told me I'm running by 1, right? So there's my next point. And now all I have to do is connect and extend, and we got it. Piece of cake, right? Okay. All right.